A satellite dish is shaped like a paraboloid of revolution. I'll talk about that in a minute. This means that it can be formed by rotating a parabola around its axis of symmetry. The receiver is to be located at the focus. If the dish is 36 feet across at its opening and 3 feet deep at its center, where should the receiver be placed? All right, let's talk about this. This is a good time just to step back, and I like applying math. Just seeing what's it all for. Where does it work in the real world? Well, parabolas are an excellent, excellent, and very applicable thing. Satellite dishes, like the one you're looking at there, that one, satellite dishes, the curvature. First off, let me say, right now in this kind of a course, this is when you're first beginning to think about curvature, and you get really more serious about curvature when you get into calculus. But let's think about curvature. If I'm driving my car, okay, driving down straight line, then all of a sudden I grab the wheel and I turn it. I can make the car curve. Now, depending on how tightly I hold that curve, if I don't hold it very tightly, it'll maybe spin further out. Or if I hold it more tightly, maybe I can go in an exact circle, right? If I hold it tight, or if I hold it even tighter, I can like spin inward, right? Really tight circle. So my point is there's different kinds of curvature. You agree with me? There's circular curvature. So when we say that this thing is a parabola, we're talking about a certain rate of bending, like how fast the curve curves, exactly how it curves. There's different kinds of curvatures. Not all curves are the same. So what does it mean for a satellite dish to be curved in parabolic curvature? Parabolic curvature. Oh, first, and let me also mention why are they saying paraboloid of revolution? What's going on with all that? Well, it's because a parabola itself is just flat, two-dimensional, like this. This is just flat. This has no depth. It doesn't come out of the board. Whereas this thing's 3D. That's what they mean. They mean if you take an axis, let me draw it for you. This is what you'll do in calculus. You'll take things like a parabola, okay, and which is flat, two-dimensional, right? X-Y axis, and they'll say, hey, take that thing now and rotate it around the y-axis. Spin it. Just spin it around, and what are you going to get? You'll get a three-dimensional shape. That's called a paraboloid of revolution. And in calculus into the first semester and beginning of the second semester, you'll calculate the volume of things that are revolved around an axis. That's one of the important applications near the end of the first semester calculus, beginning of the second semester, is you'll revolve things like that. That's what they mean by a paraboloid of revolution. So if you take a flat two-dimensional parabola and you rotate it in a circle, you rotate it and it sweeps out a three-dimensional cup, like it makes a cup kind of. That cup is called a paraboloid because all the curvature inside that cup comes from a parabola. It's all parabolic. Well, that's what a satellite dish is. That's what they literally have done. When they make a satellite dish, they revolve a parabola so that all the curvature inside the paraboloid, the satellite dish, is parabolic curvature, three-dimensional parabolic curvature, starting with a two-dimensional parabola rotated. Okay, so what? Why? Why do they make it parabolic curvature? Why are they so into that? Well, it's because, you see that receiver right here? What the engineers do when they design these things is they pick a spot for the receiver, and you know where that spot is? It's the focus point, which we know how to calculate and find the focus points now of parabolas, right? We have the equations. So why do they call it the focus point? Because here's what it does. When the things beam from outer space, from the satellites up there in outer space, when the signal comes down, it bounces. The curvature of a parabola is curved just right to make everything bounce right to the focus point. So when this satellite sends signals from outer space, wherever it hits the satellite dish, all the curvature bounces everything right to the focus point. That's what happens. It bounces everything right to the focus point. As those beams come down, they bounce right to the focus point. That's why they call it the focus. The parabola, the curvature of the parabolic surface, focuses everything, all the incoming beams, right on the focus point, or the receiver, they'll call it. That's where the receiver should be placed, is at right here at the focus point. So that's where they'll put a little receiver, because all the little things that come from the space will bounce right to that receiver. That's what they'll do. Now, do you know that's how a headlights on your car or a flashlight, same thing, work? They just run that same exact thing backwards. What am I talking about? Let me turn this into have you ever looked at at your headlights on your car? If you look in there at the mirrored surface, it's parabolic shaped. The curvature inside of a headlight is parabolic. Why? Because then they can put the lamp right here in the center at the focus point. It's all about that focus point. And then when that light shines back, the light actually aims back on the mirrored surface. And what does it do? It shines all that light straight out. It just runs the satellite thing backwards. Instead of receiving, it's sending light back on the mirrored surface, and that bounces everything straight out. That's the beauty of parabolic curvature. The curvature is just perfect to make satellite or headlights or flashlights happen like that. It's a perfect relationship between incoming or outgoing rays and the curvature bouncing everything right to or from the focus point. So that's how that works. Now, let me give you one more application because it's very important for parabolas. I think we covered this earlier. Anytime you shoot any projectile, hit a tennis ball, hit a baseball, hit a golf ball, somebody launches artillery, the travel of an object through space is parabolic. The curvature is exactly, it's not making a circle, it's making a parabola. That's if it doesn't have its own engine, right? If you have a missile, it has its own engine, it can do any shape it wants. But if we're talking about artillery, when the military launches artillery, or if you hit a baseball, golf ball, any kind of ball, it's going to fly through the air in a parabolic shape. So you can predict where things are going to land and stuff like that using parabola equations. So parabolas have many, many applications. Let's get back to it. Now, with that introduction, they want us to find the equation of the parabola, and then how far above the vertex should the receiver be placed. Now, how are we going to find the equation? I'm actually a little confused. Which way do they want me to put the equation? Let me go look at the homework real quick and see which way they want that so that I do it. I don't know if they want it going up or going to the right, because you can actually do it either way. So let me do that. Check that out real quick. And we'll do that. The parabola. All right, so they want x squared. All right, so they want it going up. All right. So I'm going to add a note about that. Find the equation of the parabola. Something about going up. Because really, technically, you could do it either way. So let me do it. So I'm going to do an axis system. You could actually make the parabola going to the right like that. Right? I mean, technically, the satellite dish is at an angle, right? You might be thinking, don't we have to do the angle? No, remember, we're just going to make this up however we want. So I'm gonna put the satellite dish like this. I'm going to have it going up. Now, again, I know that might be confusing for you. Let me say that again more clearly. The axis system is made up, right? You with me? It's made up. There's not, right? Look over here at the satellite dish. I put the origin right here, and I put the satellite dish just like that, right? I made the axis system just like this. I made this the x-axis and this the y-axis, x and y. That's what I just did, right? You with me? And then this is the top of the satellite dish right there, right? That's what I just did. Yeah, well, let me get rid of that top. That's not helpful. Anyway, that's what I just did. It's made up. There's no real axis system there. You can make it up however you want. The axis system is simply made up. Remember, that's how math works. All of math is made up, every bit of it. to help us do things that are real. So axis systems are made up. There's no such thing as an x-axis in the real world or a y-axis. We're just doing that for our convenience. So when I say I'm going to make the satellite dish go straight up, I mean I'm going to put my make-believe axis system so that the satellite dish is hitting right in the middle and going up. Could I totally make the axis system this way? So it's going to the right, make this the x-axis that way? You totally could. You totally could. You can make all the equations work that way. And you can find everything you need to find. You can make it work however you want. It's made up. The axis system is made up. So, all right, enough said. You've heard me say that a million times. I'm going to use that now. Now, if I'm making it go up, which I'm going to add that as a requirement there, it's got to be going up. Because and I'm going to, they should have said that. On the exam, I would have to tell you, like, which way do you want me to make it? I'd have to tell you, make it with the parabola going up. Okay, so if we're going to make it with the parabola going up, then that means, remember, there's some kind of focus point right here inside the parabola, right? Let's go look at our parabola examples. Here's our 4 parabolas. So if the parabola is going up, that's the equation is x squared is 4ay. And see, the focus is inside. The focus is always inside the branches. So the x squared equals 4y. If we use one going to the right, then I'd have a different equation. But we decided to make it go up. It was our choice. It's all made up. I'm going to make it go up. So it's x squared is 4ay. So x squared is 4ay. So the equation is going to become x squared is 4ay. X squared is 4ay. So we're going to do that. Find the equation. Okay. So let's do that. So now the center is 0, 0. So we don't need to mess with that. And we need to find a, don't we? So when we say find the equation, they mean find a. So you just have x and y. So how do we find a? How in the world am I going to find a? Well, I got to put some of the facts on. The dish is 36 feet across at its opening. Let's put that on there. This is 36 feet across at its opening and 3 feet deep at the center. So at the very center, this is 3 feet deep at the very center, right? So what? Well, that means this is also 3 right here. And that means this particular point is over what? 18, half of 36. You see that? If I take, here, let me do that. If I take that 36 and I divide by 2, I get 18. So that means this right here is 18. So this is over 18 up 3. Do you see that point? See what I just did? I found a point on the parabola. Have you noticed this is what we always do? Right? I just took that 36, which was all the way across. I cut it in half so that it's 18 to the right, 3 up. I know it's 3 up because it was 3 up in the center. Right? So that's to the tip top of the edge. So it's 3 up to the edge here as well. Right? From the base, it's up 3. So this is the point, over 18, up 3. Isn't it? Okay, so what? Well, that's x and y. Plug in that point. Anytime you have a point on a parabola or on any other graph for that matter, that means the x, y must make the equation true. So plug in the 18, plug in the 3. So we get 18 squared is 4a, and what is y? 3. So hit the buttons on your calculator. I'm getting 324. 4 times 3 is 12a. I just multiply 4 times 3 there. Finish solving for a, divide by 12. Boom. A equals, I'm getting 27. So we've got the equation now. So the equation right here, x squared is 4ay is x squared is 4 times 27 times y, so it's x squared. Right, I plugged in the a is 27. right there. 4 times 27, 108. X squared is 108y. So there's our equation. X squared is 108y. We got the equation. X squared is 108y. So that's the equation of this parabola, which is going up. So now, for the next equation, how far above the vertex should the receiver be placed? Yeah, the focus point, right? You have to put this receiver right here. You have to put that receiver at the focus point. At the focus point. So how do we put it at the focus point? Well, we got to find the focus point. What's the focus point? Is it the 3? No, careful. Just to be more super clear. Let me try to be super clear. The focus point is not the same. Like I'll just put the focus point up here. Just to be clear, the focus point is not the same as the tip top of the, right? You can see, even look at the picture. See how the receiver is beyond the edge? Here's the edge of the satellite dish. See how the receiver is beyond the edge. Sometimes it's inside the edge. It's not the same as the edge. In other words, are you tracking with me? It's not the same as the edge. Right? We know from the center up to here, we know this is 3 feet, right? And then it's 18 feet each direction from the middle. That's why this point is over 18 up 3, this edge point, right? Over 18 up 3. But the focus point is up here. Here's the focus. It's the receiver. Probably shouldn't be writing blue on blue. You probably can't even see that hardly. I probably should have picked a different color for all that drawing. That was not smart. Anyway, you're tracking with me, right? So I've got to find that focus point. It just kind of bugs me. I used a bad color with all that. Because that was good stuff. Yeah, let me try again. So here's the focus point, right? We know that this is the tip top edge and it's up 3 feet in the center. And that's why this is over 18 up 3 to that corner point we just found, because it's 18 each side, 36 all the way across. But this is the focus point right there, which is where the receiver is. How do we find that? Well, look back at the pictures. So when you have a parabola dish going up, the focus point is where? It's up A, right? See, focus point over 0 up A. It's always up A. In fact, you can tell right here, the focus point is always inside the branches at a distance A from the center. So whatever A is, well, we already had A right there. A is 27. How far should it be replaced? 27, done. We don't have any other calculation to do. Well, I guess, and then feet. They want you to choose the unit, 27 feet. All the units in this problem are feet. 36 feet, 3 feet. So 27 feet. They should place that receiver 27 feet from the vertex. The vertex being the center right there of the base of the satellite dish. 27 feet. That's how engineers calculate when they build a satellite dish or headlights, or where they put the lamp. They know where to put the receiver based upon these formulas. A tells you how far. A, way up here to the focus, is A, which it turns out was 27. 27 feet up to that. Is that making sense on that? Are we good there? So there we go. So we figured it out. We know where the receiver is. There we go.